Welcome to Career Guidance Max playlist. Today we are going to start MA 3351 Transformed and Partial Differential Equations. So this paper we are going to study in this third semester under Anna University. So this paper we have 5 units, but I am going to start first unit 3 applications of partial differential equations. So இருக்கிறதுல இதுதான் சிம்பிளான யூனிட் in TPD. ஓகேங்களா? So in this first I am going to start one dimensional wave equations. So that is dou square y divided by dou t squares equal to a square into dou square y divided by dou x square. So here this a square equal to t divided by m. That means tension divided by mass per unit length of the string. This one dimensional wave equation we are dealing with the string based on problems. Okay. So here we have 3 possible solutions. First one is y equal to a e power px plus b e power minus px into c e power pat plus d e power minus pat. And second one is y is equal to a cos px plus b sin px into c cos pat plus d sin pat. And third one is y is equal to ax plus b into ct plus d. So before going to start the problem, here itself you will get 2 marks. The first one is write down the one dimensional wave equation and what is a square. They will ask in Anna University question paper. So you have to write this one dimensional wave equation and what is a square. You have to write tension divided by mass per unit length of the string. After the second 2 mark, write down the 3 possible solutions of one dimensional wave equation. So you have to write this 3 equations. While doing problem, we are applying only second condition. The second condition is y is equal to a cos px plus b sin px into c cos pat plus d sin pat. So memory this. This one is very important. Why? Because while doing problem, we are applying second one only. Because when applying condition 1 and condition 3, you will not get the answer. The only possible solution is second one. So I repeat, y equal to a cos px plus b sin px into c cos pat plus d sin pat. So memory this equation. Then after this, in this one dimensional wave equations, you will have 3 types. Type 1 is zero velocity. In this we will have 4 conditions. First one is y equal to 0 when x equal to 0. And second one is y equal to 0 when x equal to L or 2L. Here I mentioned length L or 2L. Why means based on your problem we can define the length. Some problems they will give length L. Some problems they will take length 2L. So that generally I given here x equal to L or 2L. So these 2 conditions are represent boundary conditions. And the next one, third one is dou y by dou t is equal to 0 when t equal to 0, which is represent zero velocity model. So the very beginning I given type 1 zero velocity. So this third condition represent zero velocity. Why it is zero velocity? Because dou y by dou t is equal to 0. It is represent zero velocity when t equal to 0. And fourth one is I written y equal to f of x when t equal to 0. Why I written here y equal to f of x? This f of x is will change depend upon your problem. So while writing problem, you should not write here f of x alone. You have to write what they mention in the question. Okay. Here I written simply y equal to f of x, but you could not write like this. Okay. And in one dimensional wave equation, second type, non-zero velocity. So here also we will have 4 conditions. Y equal to 0 when x equal to 0. Y equal to 0 when x equal to L or 2L. Already I told why we taken here L and 2L. And y equal to 0 when t equal to 0. Dou y by dou t equal to f of x when t equal to 0. Because type 2 is non-zero velocity. So that the fourth condition is dou y by dou t is equal to f of x, non-zero, which is represent non-zero velocity. This f of x we can write depend upon our problem, we can change the f of x. So when compared to type 1 and type 2, we will change the conditions only 3 and 4. See in type 1, your condition 3 will be dou by dou t equal to 0, 4 will be y equal to f of x. In type 2, our condition third one is changed, y equal to 0. And fourth one is changed, dou y by dou t equal to f of x. Okay, here also the first two conditions are boundary conditions. Next two conditions are initial conditions. Okay. So now I am going to start the working rule for type 1 zero velocity. So before going to start the problem, here I given the procedure up to step 4. This up to step 4 is common to every problem. So while doing problem, I couldn't solve this steps. ஓகேங்களா. ஸோ பிகினிங்லேயே இந்த ஸ்டெப்ஸ் எல்லாம் நம்ம கம்ப்ளீட் பண்ணிடலாம். ஸோ இதை நீங்கள் ஒன்ஸ் மெமரி பண்ணிட்டா போதும். வைல் டூயிங் ப்ராப்ளம் we can understand more. ஓகேங்களா. ஸோ when writing the problem, first we have to write one dimensional wave equation. Dou square y divided by dou t square equal to a square into dou square y divided by dou x square. So I am giving working rule for zero velocity. Okay. Then after that we have to write the conditions. So y equal to 0 when x equal to 0, y equal to 0 when x equal to L. Here I taken x equal to L, not 2L. Okay. Dou y by dou t is equal to 0 when t equal to 0. This third condition is represent zero velocity. And y equal to f of x when t equal to 0. This one is depend upon your problem. We can able to change this f of x value. And already I told from that possible solution we have to take second condition. That is our suitable solution for this one dimensional wave equation. So y equal to a cos px plus b sin px into c cos pat plus d sin pat, which is our equation 1. So thereafter we have to apply 4 conditions in this equation 1. For what? Because of we have to eliminate this a, b, c, d. When substituting condition 1, we can able to eliminate one constant. When substituting 2, we can able to eliminate another one. Like that, we have to substitute one by one. So I am taking step 1. I am going to apply in condition 1 in equation 1. What will be our condition 1? Y equal to 0 and x equal to 0. So I am writing here y equal to 0 and x equal to 0. These values I am going to substitute in our equation 1. So substitute in equation 1, left hand side y equal to I substitute 0, right hand side x equal to 0. So I am writing a cos x equal to 0 plus b sin x equal to 0. Then c cos pat plus d sin pat. Here there is no x term, so as it is we can write. Thereafter here cos 0 equal to 1 and sin 0 equal to 0. So that I am writing a plus this entire term 0 because sin 0 is 0 and c cos pat plus d sin pat. Simplify this, 0 equal to a into c cos pat plus d sin pat. So here we have to apply trivial solution model. Whenever you will have a dot b equal to 0 means here we can take a equal to 0 or b equal to 0. Anyone not equal to 0 model. So here consider c cos pat plus d sin pat single term. This. So a dot b. So here I am taking if c cos pat plus d sin pat. For example, this entire term equal to 0 I am going to put in our equation 1. Now you can see when c cos pat plus d sin pat equal to 0 means our entire equation 1 becomes 0. We cannot able to find the solution. So it's not possible. So I am taking this is not equal to 0. By trivial solution, I am going to substitute this a equal to 0. Okay. When substituting a equal to 0, we can eliminate one term from our equation 1. So that I am going to substitute this a equal to 0 in equation 1. Okay. Substitute equation 1 a equal to 0. I will get y equal to a cos px sorry, a equal to 0 means that entire term becomes 0 plus b sin px into c cos pat plus d sin pat. Now simplify this, I will get y equal to b sin px into c cos pat plus d sin pat. So which is our equation 2. Now from our equation 1 we eliminated a. Okay, when substituting condition 1, I will get the answer a equal to 0. This a equal to 0, again we have to substitute in equation 1. I will get equation 2. Okay. After that, step 2, I am going to apply condition 2 in equation 2. What is our equation 2? Y equal to b sin px c cos pat plus d sin pat. How we get this equation 2? Based on equation 1. In that equation 1, we substituted condition 1. I will get a equal to 0. That a equal to 0, again I substituted in equation 1. I will get equation 2. In this equation, we have to substitute condition 2. What will be our condition 2? Y equal to 0 and x equal to 0. These two values I am going to substitute in equation 2. On left hand side y equal to 0, right hand side x we have to change. B sin PL and C cos PAT plus D sin PAT, as it is we can write. From this, again we have to apply trivial solution rule based on equation 2. Here again I am taking this C cos PAT plus D sin PAT equal to 0. When I am taking this entire term equal to 0, again your equation 2 becomes entirely 0. That is not possible. So again we have to take this one not equal to 0. Then I will go for B. If I am taking b equal to 0 means your entire equation 2 again 0. So that's also not possible. So here sin px, here sin pl. So I am taking trivial solution here sin pl. Sin pl equal to 0. So that pl equal to, I am writing sin I shifted to right hand side in sin inverse of 0. So pl equal to sin inverse of 0 is represent n pi. So that I will get p equal to n pi by L. Okay, I will get p equal to n pi by L. Again we have to substitute this p equal to n pi by L in equation 2. Okay, so I am going to substitute now p equal to n pi by L. So y equal to b sin p equal to n pi into x divided by L, and then next c cos n pi at by L, we substituted p, plus b sin n pi at by L. So this is our equation 3. So now again I recall in step 2. We substituted y equal to 0 and x equal to L in equation 2. When substituting this condition, I will get p equal to n pi by L. Again that this p equal to n pi by L I substituted in equation 2. I will get y equal to b sin n pi x by L and c cos n pi at by L plus d sin n pi at by L. Step 3, we have to substitute condition 3 in equation 3. But here our condition 3 will be dou y by dou t equal to 0 and t equal to 0. We can substitute t equal to 0 easily in equation 3. But we cannot able to apply dou y by dou t equal to 0 directly, because your equation 3 in terms of y. y equal to b sin n by x by L, c cos n by at by L plus d sin n by at by L. But our condition dou y by dou t equal to 0. We cannot able to apply directly. So before going to apply the condition 3, I have to partially differentiate with respect to t. This equation 3. So first I am going to differentiate this y. Partial differentiation dou y by dou t is equal to differentiation with respect to t. So partial differentiation, here there is no t term, so it is constant b sin n by x by L. Then after that, here c also constant, cos n by at by L. Here we have t, we have to differentiate this partially. Cos differentiation sin n by at by L. Then we have to write t coefficient, that is n pi a by L. Okay, this cos differentiation is minus sign, so here I written sign only. Now I am writing here this minus. So cos n pi at by L differentiation is sin n pi a minus sin n pi at by L into n pi a by L, and plus the second term d is constant, sin differentiation cos n pi at by L, and inner term differentiation with respect to t, I am writing again n pi a by L. Now we differentiated that equation 3. So now I am going to apply the condition 3. What it is? Dou y by dou t equal to 0 and t equal to 0. I am going to substitute in the above equation. So here you can apply this dou y by dou t equal to 0, and right hand side b sin n pi x by L and minus c n pi a by L and sin t equal to 0, and plus d n pi a by L cos t equal to 0. Simplify this. 0 equal to b sin n pi x by L, and this sin 0 means the entire term 0, plus d n pi a by L. Cos 0 is 1, we know that. Now you can multiply both the term and simplify. B d n pi a by L and sin n pi x by L. Now we can compare equation 3 and this term. Here again by trivial solution, if I am taking b equal to 0 means your entire equation 3 again 0 when substituting b equal to 0. So this is not possible. Then sin n pi x by L. If it is sin n pi x by L is equal to 0 means again your entire equation 3 becomes 0. That's also not possible. So I am going to put this is also not equal to 0. And n pi a by L, there is no term n pi a by L in equation 3. So this is not equal to 0. Okay, the only possible term here d equal to 0. If I am taking d equal to 0 means we can eliminate one term from equation 3. So I am going to substitute this d equal to 0 in equation 3. So I will get y equal to b sin n pi x by L and c cos n pi a t by L, and this entire term 0. Okay, so simplify this. I am writing y equal to bc sin n pi x by L and cos n pi at by L. When substituting d equal to 0, we will get the equation y equal to bc sin n pi x by L cos n pi at by L. Thereafter, we cannot be able to eliminate this bc because all the terms are in product form. Here we cannot be able to take bc equal to 0 or c equal to 0 or sin n pi x by L equal to 0 and cos n pi at by L equal to 0. We cannot be able to take. So this bc constant I am going to put bn. So I am going to put bc equal to bn. So I will write y equal to bn sin n pi x by L and cos n pi at by L. Okay. So here generally we written the constant bc equal to bn, but we don't know what is this n. So this n I am going to write by the superposition principle. I am going to define this n is equal to 1 to infinity number of terms. So that I am writing the most general solution. The most general solution is I am writing y equal to sum I added n equal to 1 to infinity. Why we written summation of n is equal to 1 to infinity? By superposition principle, we defined constant here bn, so that n we have to know what is that n value. So we can take generally 1 to infinite number of terms. So sin bn into sin n pi x by L and cos n pi at by L, which is our equation 4. If you are writing up to equation 4 now, in university exam you will get 8 mark. And step 4. What is step 4? In step 4, we have to substitute condition 4. Condition 4 in equation 4. What will be our condition 4? Our condition 4 is y equal to f of x, non-zero term, and t equal to 0. This f of x depend upon your problem will change, because here I given general working procedures. While doing problem, you have to substitute what is that f of x. Okay, and the left hand side I am writing y equal to f of x, and right hand side I am writing sum of n is equal to 1 to infinity bn sin n pi x by L into cos n pi at by L. So here I am going to substitute t equal to 0, means this entire cos term is 0. Cos 0 is already you know that 1. So that I am writing sum of n is equal to 1 to infinity bn sin n pi x by L, right? And left hand side f of x. Already I told this f of x is depend upon your problem. According to your problem, will change this f of x value. Okay, and right hand side is represent what? Do you remember that in unit 1, unit 2 you are studied Fourier series. In that Fourier series, half range sine series general form is this one. General equation f of x equal to sum of n is equal to 1 to infinity bn sin n pi x by L, which is represent half range sine series, right hand side. So that if it is half range sine series, we can able to find bn. How to find bn? We can able to find bn. The bn formula is bn equal to 2 by L integral 0 to L f of x sin n pi x by L into dx. Here this f of x given in your problem. Okay, so after you are writing step 4, you will get 10 mark out of 16 mark. Okay, remaining 6 mark is for finding bn. After finding bn, this bn value we have to substitute in equation 4. When substituting equation 4 bn value, your problem will be over. So this is our general procedure. Again, we will revise once again what we completed in this video. So I will recall again. Uh, while doing problem, we have to classify our problem will be under zero velocity or not. If you are identified our problem will be zero velocity model means this is the procedure you have to write. Okay, first you have to write one dimensional wave equation. Dou square y divided by dou t square equal to a square into dou square y divided by dou x square. After that you have to write the conditions. What are all the conditions? Y equal to 0 when x equal to 0, y equal to 0 when x equal to L. Most probably your length will be L only. Very few problems only they are taking 2L. Okay, so that here I taken L, and dou y by dou t is equal to 0 and t equal to 0. This is zero velocity model, so that dou y by dou t equal to 0 always and t equal to 0, and y equal to f of x when t equal to 0. This y equal to f of x, this f of x is depend upon your problem. Here I solved, generally I taken f of x. While doing problem you can take what is given in your problem, you can write here, you can mention here. Okay, y equal to f of x when t equal to 0. So already I told this is our suitable solution for solving one dimensional wave equation. What it is? Y equal to a cos px plus b sin px into c cos pat plus d sin pat. Okay, this is our equation 1. Now I am going to apply that 4 conditions one by one. Step 1, step 2, step 3, step 4, like that. In first I am applying condition 1 in equation 1. When I am substituting condition 1, y equal to 0, x equal to 0, I will get a equal to 0. This a equal to 0, again we have to substitute in our condition equation 1. I will eliminate one constant a. I will get equation 2 is y equal to b sin px into c cos pat plus d sin pat. Now you can forget equation 1. In that equation 2, I am going to apply condition 2. What will be our condition 2? Y equal to 0 and x equal to L. Again I am going to substitute this one in equation 2. So left hand side 0, right hand side you will get one equation. We have to compare, already I told we have to compare this equation 2 and this term, which one equal to 0, which one not equal to 0 model. Here I will get p equal to n pi by L. This p equal to n pi by L, again I am going to substitute in condition 2. I will get equation 3 when substituting p equal to n pi by L. So after that, in this equation 3, we have to substitute condition 3. But our condition 3 is dou y by dou t equal to 0 and t equal to 0. Our equation is in terms of y. We cannot able to apply directly this dou y by dou t equal to 0. So that before applying condition 3, I will partially differentiate with respect to t in that equation 3. So differentiation term, here I am going to apply the condition 3, dou y by dou t equal to 0 and t equal to 0. I will get this equation. So after this equation, now again we have to compare with equation 3 and which one not equal to 0, which one equal to 0 we have to define. Here I will get d equal to 0. This d equal to 0, again we have to substitute in that equation 3 only, not differentiation term. In that equation 3 we have to substitute d equal to 0. I will get equation y equal to bc sin n pi x by L into cos n pi at by L. So thereafter we cannot be able to eliminate this constants bc. So generally we can take bc equal to bn. When we substituted bc equal to bn, we have to define what is that bn. The most general solution by superposition principle, I am defining this value is 1 to infinity because of n constants, we don't know what it is. So we define 1 to infinity bn into sin n pi x by L cos n pi at by L. This is our equation 4. In this equation 4, I am going to substitute condition 4. When substituting condition 4, I will get right hand side equal to half range sine series model. Half range sine series model means we can able to find bn directly. Bn equal to 2 by L interval 0 to L f of x sin n pi x by L dx. Here we can apply f of x value based on your problem. I will get bn. This bn value again we have to substitute in equation 4, the most general solution. That is our final solution. So in this video I given general steps up to step 4. It is common for zero velocity model problems. You have to write up to step 4 every problem. You will get minimum 10 marks. After 6 marks, we have to solve Bn. In next video, we will solve non-zero velocity working rules.